record here. We found common denominators by multiplying the numerator and the denominator on each fraction by whatever number would link us up with the other denominator and a multiple of that guy. So for example, perhaps we have forgotten. To check, you can use your multiplication tables for this, or we can write them out. 2's go up by 2, 4, 6. 3's go up by 3, 6, 9. Oh, look, 6 is where they meet. Using your multiplication tables for this makes this a lot easier because you can see very easily what I have to multiply 2 by to get to 6. Well, 2 times 3 is 6 times 3, and this one's going to be times 2 and times 2. I'm just doing the first one as an example. Then you would have gotten 3 over 6, and you would have gotten 2 over 6. And the question was, this time, determine which is larger. And so you would have said, yes, 3 over 6 is larger. So this is the larger one, and I would have circled both of those things. Okay? So this is what I wanted you guys to do yesterday. Like I said, there was 10 questions here. Some of you did more because you took the second sheet. But this was where I wanted you guys to start. So I'll tell you what all the answers are, and then if there's any you want me to do, I'll take some time to do that, and then we're going to start looking at converting fractions to decimals. So number 2, that one is going to be the one that is larger. This one, number 3, that's going to be the larger of the two. That's going to be larger. That's going to be larger. This one's going to be larger. Number 7, that's a half, so that one's going to be larger. I'm going to star number 7. I'm going to come back and talk about 7 because there's a really nice way to do number 7. Number 8, I actually have to do, so that's going to be the smallest number that 8 and 6 both go into is, anybody? 24, Dakota, thank you. So to get to 24, I multiply top and bottom here by 4, I multiply top and bottom here by 3, and we're going to get 20 over 24, and we're going to get 21 over 24. So this one is the larger of the two. Over here, it's going to be that one, and then down here, it's going to be that one. Is there, other than number 7, which I'm going to do here in a second, or is there any questions on there that anyone would like me to do? Okay. So what I'm seeing is all y'all did all 10 questions, and all of you have no questions about these 10. So if I walked around and checked, that's what you'd be able to tell me. You should see nodding from someone that I know finished, because she finished early. Okay, just out of curiosity, I want to come and take a look. We're doing Heather's out. Where's yours?
I lost it.
Where's your phone?
In my pocket.
Show me. Fantastic. Now you're good. You lost it. Lovely. Okay, you guys are done. You're circling. You finished some of them, and now you're circling more now. Okay. Okay. You didn't even try to circle around the right answers. You didn't do it. Okay, cool. Yeah, we didn't do it. We didn't do it. You're done. How do we do? Okay, you got it. Wow, yeah. Cool. Cool. You did not finish it, did you? Okay. Okay, so. I'm just going to give it to you. Hang on to it this time. And here we go. I want to show you something, a slick trick with number 7 to make your lives easier. If we look at this thing here, we can see that 16 and 24 are fairly large numbers. If I want a number that 16 and 24 both go into, we could do that. I don't know how many of you know your 16s times tables, but 16 and 24 are both do go into 48. We could do that. Or we could take a look at this thing and say, okay, can I reduce these fractions first? Can I simplify these things, which is something we did together a couple days ago? Can I do anything to simplify 4 over 16? Hassan, can I reduce 4 over 16 at all? Can I simplify it?
Yes.
I can. What do I, why? What can I divide 4 and 16 by? Yes, thank you, Liam. I can divide them both by 4. 4 divided by 4 is 1, 16 divided by 4 is 4, and I can do something similar over here. What can I divide 12 and 24 by? Preferably to give me a same denominator. What can I divide 24 by to get 4? Danny? 6 is correct. Divide by 6. 12 divided by 6 is 2. 24 divided by 6 is 4. Oh, look! There's the bigger one. You could multiply up to 48, but by looking and seeing if you can apply, Hamid and Abdullah, any of the skills that we've already done, can make your life a little easier. Again, math classes are all about adding things to your toolbox that you can then, pull out and use on any given question. Okay, so there's that. This is the stuff I did yesterday. Does anyone want to ask about any of these questions or? Okay, well, there is a quiz coming, so we'll see how she goes. Yeah. It's not today, but it is soon. Okay, I would like you guys to find this page in your notes. It is page, on the bottom it says page number 18. On the top it says steps to convert fractions to decimal numbers. First, I'm going to show you a technique, some things that will make your life easier, and then I'm going to show you a shortcut. Well, first the long cut, then the shortcut. Okay, so here we go. Has everyone found this page? Zach, have you got this page out? It's page number 18. It says 18 on the bottom, and on the top it says steps to converting fractions to decimals. Okay, so some of you are going to like the tricks. Some of you are going to like the shortcut. Let's do them both. So, here are the tricks. When you're converting fractions to decimals, there are a set of fractions that are actually pretty easy to commit to memory if you can connect them to other things in life you're already familiar with. For example, I'm hoping, I would think, that most of you would be familiar with, not all of you certainly, but most of you are going to be familiar with Canadian currency. And one of Canada's most popular coins is the, yes, smaller than a loonie, because a loonie is a whole, and I don't want holes, I want fractions, the quarter. Quarters are very useful for a whole host of things. If you're only familiar with one Canadian coin, smaller than a loonie, it's got to be the quarter. Quarters are nice and easy. It's in the name, for those of us who are familiar with Canadian currency. This is a quarter. And if you think about a quarter, as far as money is concerned, we don't typically think about a quarter as being 1/4. Often we take a look at a quarter, and what number immediately jumps to mind? 0.25. 25 cents or 0.25 of a dollar. So this is a really easy conversion to make. A fourth is 0.25, and it's something you've likely already done. It's in the name and you take it to the decimal. But actually formalizing it in the context of math is something that we're going to do here now. And multiples of quarters is something that you should be familiar with too. Because if I have 2 quarters, that's, well, 2 quarters, how much money do you have? You have 50 cents, or 0.5 of a dollar, 0.50, 50 cents. If I have 3 quarters, how much money do you have? I have 75 cents, or 0.75, $0.75. And then, well, 4 quarters is easy because if I have 4 quarters, you've got how much money? $1. So those are easy to deal with. Is that a hand, Dakota? No, that was not a hand. Let's take the money and go a little bit smaller. The next coin down is a dime, and a dime is worth what? 10 cents. Well, 10 cents is, how many dimes do I need to make a dollar? 10 of them. So 1 dime is 1/10 of a dollar because you need 10 of them. Tenths are easy to do as fractions, especially if you connect them to money. If I have 1 dime, that's 1/10 of a dollar. What's a dime worth? 0.10. If I have 2 dimes, that's 2/10. That's how much money? Well, you're making eye contact with me, and you knew the first one, so I was lobbing you a softball, Garrett.
0.2.
Done. 0.2. If you don't want to think about them in the context of money, another way to think about tenths is by saying, well, okay, whatever it is just 0. The numerator is the shortcut. So 3/10 is 0.3, 4/10 is 0.4, and it's nice and easy. The next coin down is a little trickier. We're not gonna, you know what? Let's leave it at quarters and dimes. The nickels get a little bit dicey. We can ignore nickels. Does anyone? Now we're going to start getting into some of the memory tricks we have for some of the other fractions. Does anyone know off the top of your head any of those nice, easy conversions between fractions and decimals? Things maybe you've seen before, like in middle school, for example. Those other kinds of easy fractions. Yes. Yeah, you, man. You had your Jared, your hand in the air.
No.
You were so serious, you had 2 hands in the air. So there's no fractions in there that you're like, I know this fraction is this decimal? No? Okay. There's some easy ones. If you need some memorization tricks, the next easy one are the ninths. And the ninths are going to give us another set. So if you can remember the ninths, you actually get 2 for free. And the ninths are really easy. The trick for the ninths is that the ninths are, well, I'll show you the first one. 0.1 repeating. So also you guys have written as 0.1111111 forever. The ninths are just whatever the numerator is going on forever. So 2/9 is, anyone want to take a guess? Yes, 0.2 repeating. The next one is the one that we get for free. 3/9 is going to be, Dakota? 0.3 repeating, but I can reduce 3/9. What can 3/9 reduce to? I can divide them both by 3, and if I do that, divide by 3, divide by 3, what other cool fraction do I get here? Yes, I get 1/3. So the ninths are the numerator repeating, but 3/9 is the same as 1/3. I get this guy for free. Which I'm going to leave the 4/9 and 5/9. Those are the same as what we've seen before. I'm going to jump straight to the 6/9. 6/9 is going to be the numerator repeating every time for the ninths. So 6/9 is 0.6 repeating. So it's a line above it. 0.6 repeating. But the reason I jumped to this one is because we get another fraction for free. 6 and 9 are also both divisible by 3, and so I'm getting another free fraction. What free fraction am I getting? Garrett?
2/3.
Getting 2/3. You betcha. And so just we'll skip 7 and 8 because those are just 7 and 8. I want to take you to 9 because 9's weird and kind of fun. If you like math things and you're like, that's weird and uncomfortable, I'll show you this one. By following the rule for ninths, which I'm now going to write down here, ninths are just 0 point the numerator repeating. That's what that line above there means. It means it goes on forever. 0.111111, 0.2222222, whatever it is. So 9/9 is supposed to be what as a repeating decimal? Yeah, it's going to be 0.9999 going on forever repeating. But what is a number divided by itself? Also going to be equal to 1. And what that means is that 0.9 repeating and 1 are actually the same number, which makes some people very angry. I got into an argument with my student teacher, like a full math degree, coming to here to learn how to be a math teacher, student teacher 2 years ago. We got into an argument about this. She decided she was going to argue with me. She was 21. I'm 36 and been doing this for as long as she's been alive. Like, no, girl, you're wrong. This is weird. It makes people uncomfortable, but it's cool. Math can be cool. So we've got fourths connected to money, tenths connected to money. Ninths also give us the thirds, which really only requires one more, which we can also get for free. We just didn't talk about it before. The other nice, easy one to look at is the fifths. What's 1/5? Take a look. It's actually already on the page somewhere else. Where else is 1/5 on the page? Not written as 1/5, but you can jump to 1/5 pretty easily. Does anyone see it on there already? Dakota? Sorry? Nope. 1/2 is not on there. Nope. 1/5 is somewhere else. 1/2 we're going to jump to in a sec. Which one of these other fractions can I take to 1/2? I can take 2/4. Now is not a great time. Are you? Sorry?
I get 1/3.
Yeah. Are you dying?
A little.
Okay, as long as you're not totally dying. A little bit of dying builds character. Okay, 2/4 we can drop to 1/2 because both of these are divisible by 2. 1/2 is the same thing as 0.5. There's one of these on here that we can drop to 1/5 using the same technique. Which one of these is going to, by dividing by something, is going to take us down to 1/5? Not 1/10. Next one. No, this way. Nope, this way. 2/10. If I take 2 and I divide it by 2, I get 1. 10 divided by 2 is 5. So we can actually draw a line between these two as well. 2/10 and 1/5 are going to be the same thing. Those fractions are equivalent. And then everything, all of the other fifths, I mean, we can pull them out of the tenths. But we can also, if we can remember this one, we can just multiply our way up. Just doubling it every time. So if I, or not, so that's not true. You're just multiplying it by whatever the numerator is. So for example, if I want 2/5, I'm just going to double 1/5. What's 2 times 2? 4. So 2/5 is going to be 0.4. If I want 3/5, well, that's just 1/5 times 3. So what's 2 times 3? 6. Or 0.6. And that works for all of these. Multiply your way up for all of these. So, for those of you who are like, yeah, I can crank some of these out in my head, you will always be faster. It'll always be easier for you if you can connect it to something that's already drilled into your brain. So for those of you who have some of them already, or can make those connections, if you can remember this column right here, and really, if you can remember these three, all of the rest comes super easy. For those of you who perhaps want to opt out of making your life a little easier, what is a fraction? I've said that I've explained what fractions are already. Who remembers? What is a fraction really? Numbers doing what?
Coming lower.
Through what mathematical operation? Division. You should have, Hassan. A fraction is, I'm going to underline that, division. That is what a fraction means. It means you are taking the numerator and you are dividing it by the denominator. And we have two ways to do this. If you want to be wild, gentlemen at the back, Hamid and Abdullah. Guys. There are two ways to divide in math class. The awful way to divide is to do what? Long division. Long division is the terrible way to make this happen. If you feel like inflicting cognitive pain on yourself, by all means, long divide. Or, what other cool tool can do this for us? Your calculator. And that's all this is. And I have students all the time, I give them a grade on a test. They go, oh, you got 15 out of 20. They're like, what's my grade? Well, it's 15 out of 20. What percent is that? Well, just do the division. You've got a calculator for this. I would like all of you to pull out a calculator. If you have one, today is the day you get to use them. If you do not have one, I want you to come get one. And the way you get a calculator from me is by giving me your phone and exchanging it for a calculator. Come do it. No, I want your phone. I want something that I could sell and get more calculators. No, I want your phone. I want your phone. I want you to put it right here.
What if I give you a good handshake?
I can't sell a good handshake for anything. But you already have your calculator, so it's like a free handshake.
Can I get water?
Come get a calculator. Go really fast. I want you to run. What are you doing? What is so... Just lock it. Put it right here. Because I don't think, if it's not an iPhone, I don't have the right charge port for you. And take a calculator. Do you have a calculator? No, we don't. No, that is not a word we do not describe calculators with a sexual orientation. Not appropriate.
Okay.
You can say, I don't know how to use it, so I don't like that calculator. That's fine. Take one you're comfortable with, and I'll teach you how to use it. Don't take this one because it's missing some buttons. I'll keep this one. That's a great one. It's the same as the pink one you just said you didn't like. Pushing the on button, bottom left, it says on it. Bring me your phone. I'm serious, guys. Get a calculator out if you haven't already. You have a calculator? Fantastic. You're not allowed to use your phones as a calculator. Zach, you got a calculator? Bring me your phone and come get a calculator. Bring me something. Come over here and leave a shoe.
Is that your booklet you just found? Yeah.
Nice. Love it. So y'all got calculators. I want you on this page. I want you working with us until the lesson's done. No, if you have a phone, I want the phone. You got. So if I see a phone from Zach, I'm taking the phone. I'm keeping it for the day. But don't lie to me. Yes, I want you. Yes, if you don't have one, I want you to get a calculator. Okay, so really all this is because a fraction. Now all of you have calculators in front of you. I'll show you how to use them. Garrett, do you have a calculator? Then what did I just tell you to do? I told you to come get one. Not right now. I told you to come get one and leave me your phone. So come get a calculator. Get up. Come get a calculator and leave your phone on the table. Get up.
Can you drink water?
Not right now. Thank you. Leave your phone on the table. Come grab a calculator. Okay. They all work the same way. Even the translating device, that is a bold move. Okay. So for all of these, a fraction is just division. You can do this on your calculator relatively easily. It's just remembering that this is true and then operating in your calculator. I won't use this one because you can't see the buttons because someone wiped them all off. So I'll use this one, the one that Hassan didn't like, my bright pink calculators. A fraction is just division. So if you want to do any of these, it's really easy to do. If I want 2 over 9, let's show you. 2 divided by 9. That is what these fractions mean. Enter. There it is. 0.222222222 repeating. Forever. Then you didn't do 2 over 9, you did 5 over 9.
Well, I did get that.
Okay? That's all this is. Fractions are just division. Take the numerator, divide by the denominator. Done. Okay. So, this is going to make the next step easier. Flip the page. What if we don't have just decimal or just fractions now? Now what we've got is decimals. I know, right? It's awesome. I have mixed fractions. I want to turn those into decimals. To take a mixed fraction and convert it to a decimal, here's what you got to do. What you need to remember, well, there's 2 options for this. There's method 1 and method 2. Method 1 is to say, okay, I want to take this thing and I'm going to convert it to an improper fraction, and then you either long divide, which is fun and awful for some of you, or you can now use a calculator. For your guys' test, I'm going to have 2 sections of a test, a calculator section and a non-calculator section. Everything we've done up to right now, I should expect you to be able to do without a calculator using your multiplication tables. There will be a calculator section where we bring in this. So, one way to do this is to convert the mixed fraction to an improper fraction and then use a calculator. So again, now that you got a calculator in front of you, you could start converting this using that tool. But you still need to remember what the technique is. Does anyone remember how to take a mixed number and turn it into an improper fraction? What do I do? You don't divide them. Not yet. That's the next step. Dakota. Yeah, I take the denominator, I multiply by the whole number, and then what do? I multiply, yeah, and then what?
Then you add the 9 to the one that is just 10.
Right. So I take the denominator, I multiply it by the whole number, 9 times 1 is 9. And then I add that result to the numerator. So I multiply here, and I add what I get up top. So 9 times 1 is 9 plus 1 is 10, and I leave the denominator the way it is. Now we're undoing a whole bunch of the work I got you guys to do yesterday. And now you can take this thing and you can punch in your calculator. What's 10 ninths? Well, that's just 10 divided by 9. It's always numerator over denominator. Well, that's going to be, yeah, 1.1 repeating. Or you can write it as 1.111111. That's what this symbol means for those of you who may never have seen it before. So then what's this guy going to be? If I do this by the same technique, I want to take this thing and I want to turn it into a decimal using this method. First I convert it to an improper fraction. 3 times 3 is? 9 plus 1 is? 10. So this is going to become 10, and the denominator stays the way it is. I've got 10 over 3. Well, a fraction is just division, and it's always, and some people are going to mess this up because I see it every year, not because I'm judging you. I'm just going by past experience of teaching grade 9 for a really long time. Well, and 11. 10 over 3 is 10 divided by 3. It's always top divided by bottom. It's going to be 3.3 repeating. That's one way to do this. Yeah, the sharpener's up by the door. The other way to do this, and again, I don't care which method you choose. You have two options. Pick one that you like and roll with it. Method 2 says, here's what you do instead. I'm going to zoom in on the second one, or the first one here. Method 2 says, leave the whole number alone and just convert the fraction. Because really what you have here, this is the same as 2 plus 1 over 5. If I want to take this thing and convert it to a decimal, I can leave the whole number alone and just look at the fraction piece. 1 over 5 was one of those ones I told you would be easy to memorize, or we can just go straight to the calculator. 1/5 is what? This thing is 0.2. So if I have 2 plus a fifth, that's going to be 2 plus 0.2, which is going to give me what? 2.2. Thanks, Garrett. I leave the whole number alone. I just convert the fraction in my calculator, or the one from one I've memorized, and then I add that whole number out front. So this one would be, if I have 3 and 1/9, it's going to be 3 plus, what is 1 over 9 as a decimal? Nope. The ninths are always the numerator repeating. So 1 over 9 is, or you can punch in your calculator, do the division. 1 over 9 is 0.1 repeating. It's going to be 0.1 repeating. So 3 and 1/9 is the same as 3.1 repeating. What's wrong with the last one? The last one is different than anything we've done yet because we're not supposed to write the last one the way we've written the last one. What's stupid about the last one? I do mean stupid. You'll never see this anywhere else other than a math teacher trying to get you. Garrett. It's improper and it's mixed. In the real world, you never see this. This is just the kind of question a math teacher cooks up to get you. So let's do it. This is the same as 4 and 5 over 2. If you remember to treat this thing, leave the whole number alone, and treat it like you're adding these two things together. Zach, are you following with me up here? And we can take 5 over 2 and we can punch it into our calculator. What is 5 over 2? Well, it's actually a whole number and a decimal already because it's an improper fraction. So if I remember to treat it like that, this thing's going to become 4 plus 5 over 2 is 2.5. And then to add these two things together, I just add my whole numbers. 4 and 2 is 6 plus the 0.5. So you're never going to, again, outside of a math teacher trying to mess with you, you're never going to see a whole number and a mixed number with an improper fraction inside. It's not going to happen, except here. So, the reason why yesterday we looked at comparing fractions, finding common denominators, and the reason we're looking at converting fractions to decimals is, if you remember how we started yesterday, so I started yesterday by asking you guys how to compare the size of numbers. Which numbers are bigger? How do I order these things? What's my smallest? What's my biggest? And how do I order them all in between? Well, using the skills we did yesterday and the stuff I just showed you, what we're going to start to do is we're going to start to put these things together. And I want you guys to be able to take a collection of numbers and order them from least to greatest. Because having a sense of how these things work is an important skill to be able to have. To be able to compare the size of numbers relatively easily is important to be able to do. So, if you've got a long string of numbers like this, you've got two options. Again, and I don't care how you choose to do this. Either you can put all into the same fraction to compare them like we were comparing them yesterday. You could make all of these fractions have the same denominator. Or you can take a calculator to each one. Convert them all to decimals and then order them that way. So we're going to do this one together, and then I'm going to free you. We're going to skip the next page, and we're going to free you to play with these. Here's what this is going to look like. These are the fractions that we have, and this is what I want to order. I could put them all into the same fraction with a common denominator, but I've got ninths, fifths, halves, and thirds. That would be a large number to do. It would actually be 90. I don't want to do that. So what I'm going to do is I'm going to take all of these things and I want to convert them to a decimal. I'm going to do that work above. So what is 4 over 9 as a decimal? Crank it out in your calculator. Tell me when you've got it. 0.4 repeating. Or you can use the tricks I've taught you. What is negative 2/5 as a decimal? Division. Push the division button. What'd you get, Hassan? This one. 2 over 5. Negative 2 over 5. Okay, let's try. That's all we want to make sure we hit. 2 divided by 5. And it should be negative. Good. We're going to leave 2 alone because it's already a whole number. A half is, you can use your calculator or you can memorize it, 0.5. I'm going to leave the whole number alone. And 1 and 2/3 is going to be what? Liam's cranking these out. So now I'm going to compare the red numbers that I've got and the 2 integers that I left alone, and we're going to order them from least to greatest, and then we're going to put them on the number line. What is the least value of all of these numbers here? Which one's got the lowest value? We're also comparing, don't forget these two integers. Garrett?
0.5.
No, it's not 0.5. Least, the more negative you are, the lower the value is. Remember, yes, Sahil, -1. -1 is the one that is the least, it's the most negative here. So it takes the position of the least value. That guy's done. Cross him off. Next one. What is the next either most negative or closest to 0? The negative 0.4 is going to show up here. Next one. 0.4 repeated. Because now there's nothing else negative. Now we've crossed over to the positives. So the next least one is going to be 0.4 repeating. Because 0.4 repeating is 0.444. Okay, that's that guy. The next one, 0.5 comes next. 1.6 repeating, and the last one is 2. So then after I've got that one, we're going to throw them on a number line. The number lines that I give you are always going to look like this. I don't know if anyone's counted yet. There are 21 lines on here, which means it's really convenient to be able to put 0 in the middle and go 10 in either direction. But, again, if you recall to a couple days ago, we can use whatever scale we want here. Like Dakota, last time we did it, you went up by halves, or you went up by 4s, I think last time we did these things. Take a look at the numbers that we've got here. We've got -1 all the way up to 2. We don't have to go up by 1s here. We can spread this out a little bit if we want. Don't worry, I'm almost done talking. And then those of you who are thirsty can go get a drink. Zach, are you with me here? Okay. You want to, I would consider, because these numbers are so small, and I've got lots of lines here, I would consider going up by something small. If I call this guy here 0, where's right in the middle? Boom, 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 boom. Almost done, guys. You guys got to hang on there. Let's call this guy right here 0. If I go up by 2s, then that one's 2 already, and I'm cramming all these numbers into that little space. What if I call every other line 2? Or, I mean, that's just me calling every line here 1. What if I call every 4 lines 2? There's all sorts of different scales you could pick here. But don't make them too big, right? If I call this 1, 2, 3, 4, and -1, -2, -3, -4, then all of these numbers are going to get crammed in here. That might not be a great way to do it. So if you're just blindly writing down everything I'm writing down, we're going to erase that. If I want to spread it out a little bit, I could say, okay, these 2 lines are 1, then 2 more lines is 2, then 3, and then I go this way. 2 lines is -1, 2 more lines is -2, which makes that middle line what? 0.5, because it's halfway between 0 and 1. So then this line here is going to be 1.5, and 2.5, and -0.5, -1.5. And we go in order from 0 out in both directions. And now we're going to place these numbers on that number line, and then I'm going to free you, and I'm going to come around and help where needed. So 2 is already on the number line. 2 is right here. So we're just going to put a mark where 2 is. I'm going to write 2 above it. That guy's done. Where is 1.6 repeating going to show up on this number line? Right before this 2? So like in between here? You bet. You can throw it right here. 1.6 repeating. Boom. 0.5 is going to show up where? If you look at what I've done here, 0.5 has its own line already. Where's 0.4 repeating going to show up? Right before 0.5. Where is negative 0.4 going to show up? The negatives are the ones that we got to be careful with. What do you mean right after the 0? It's going to be between 0 and negative 0.5. You bet. So we can put the negative 0.4 in there. And then negative 1 has its own line already. And we're done. If you had decimals in this list already, we could leave them as they are, because I'm not going to get you guys to convert decimals into fractions. We're going to leave that alone. But this is what you guys are going to practice today. Converting these numbers and then ordering them all on a number line. Fractions and decimals too. Okay, here's what I want you to do. There are 4 questions. And you got 25 minutes to do them. I want you to take a look at these. I'm going to come around. I'll help where needed. God's going to help where needed. Question 1, question 2, flip the page. Question 3 and question 4, then you're done. And the instructions for each one of those is the same. Skip the page with decimals. Jump ahead to here. I want you to convert all those numbers and put them from least to greatest on the number line. That's what I want you to do. On your mark, it said go.